Okay, so this is the first video for the General Chemistry CHE 109. So I am your instructor. My name is Puriya Kemali. My office hours are on Fridays from 2 to 3 p.m. EDT, the local time in Lexington, Kentucky. And the office hours are going to be over Zoom, and the link is provided in the syllabus in Canvas. If you cannot make it from 2 to 3, you can ask for a different time. We can set an appointment and meet over Zoom. My email is simply my first name dot my last name at uky.edu. So purya.kamali@uky.edu. So for the first day of class, you can access the Achieve with any Achieve assignment in the Canvas. You can click on any of them and it will direct you to the Achieve, and you can make up your account. The charge for the Achieve is going to be billed to your student account on UK. We're going to have 3 exams and 1 final. The exam dates are listed in here, and it's also in the syllabus. The exams are open from 9 to noon, and it's online. And the time is again the Lexington time. The 3 exam is a 60-minute exam, and the final is a 2-hour exam. It's recommended to start early, so if anything happens, we can fix it early, and you can finish the exam before the noon. For recitation, we're going to have a worksheet every week, and that's going to cover the topics that we covered during that week. It's going to be graded based on 1 random question, and each worksheet is going to have 4 points. The lowest grade for the worksheet is going to be dropped by the end of the semester, and I'm going to record a video for solving the worksheet and going to upload it in the Canvas. It's better for you to first try to solve it yourself, and if you have problem, you can go back to the video that is uploaded on the Canvas. So the grading for this course, for some reason this image doesn't show the percentage that I uploaded in there, but the exams is going to be the most, it has the, let me see, okay. So it has 51% for exams. Let me write exams. And 22% of the grade is for the final. 10% is for play posits, and 7% for recitation, and 10% for the homeworks. Okay, so now let's start our first topic. So atoms and molecule, those are the terms that you probably heard about that in your high school chemistry or any kind of chemistry course you've ever had. So what is atom? What are atoms? So atoms are submicroscopic particle. And why do we call it submicroscopic? Because microscopic particles are the particles that you can see with a microscope. Submicroscopic particles are the particles that you cannot see with a microscope. So these are the particles that constitute the fundamental building block of ordinary matter. And that's the first time we see the word matter. So what is matter? Matter is anything that takes up space and it has mass. So, mass. Let me erase this. Okay, so we're going to talk more about mass and the classification of mass. So what is molecule? Molecule is 2 or more atoms that are bonded together in a particular geometric arrangement. So for example, that's one of the most famous examples of a molecule, H2O, water. Everyone knows that H2O is water, and how they are bonded together. We know that two hydrogens are bonded with oxygen with this geometry. So that is an example of molecule. So what is chemistry? Chemistry is the study of matter. Again, we have this word, matter, and we are going to talk about it more in the next videos. So it's the study of composition, properties, and interaction of matters. And this study is based on observation and experimentation, and that's basically what any science is based on. So we have observation and we have some experimentations, and that's what's called scientific method. So scientific method is a process that combines observation, hypothesis, and experimentation. And these are three key words, and they're important. So it starts with the question, what background data or observation do you have? You always see something, you have some observation. So it starts with an observation. What is your initial explanation? This is a key word, initial explanation. So when you see something happens, with your data, you have an initial explanation. So that initial explanation is hypothesis. So that initial explanation is your hypothesis. How can you check it? You have to design experiments. So the first step is have an explanation, and that's your initial explanation over whatever you observed, and that's your hypothesis. The next step to check it is designing some experiments. So the next step is experimentation. And if your experiment supports your hypothesis, that's going to move forward and become a theory. And we're going to talk more about this. So hypothesis, theory, and law. What is hypothesis? As we said, hypothesis is the initial explanation. So that's whatever initial explanation come into the mind with your background data and knowledge that you have. You come up with an explanation of the observed fact, and that's your hypothesis. When you have your hypothesis, you design some experiments to check if your hypothesis is true or false. So if your experiment supports the hypothesis, then that hypothesis will be upgraded and become a theory. Theory are usually broader in scope and explain and predict many different observations. That's going to be accepted with different scientists, and it's going to be applied for other kind of observation which is linked to the initial to this kind of theory. Scientific observations that are always true are referred to as scientific laws. Scientific laws are statement of phenomena without explanation. There is no explanation for the laws. Like, for example, when you throw something up, you know it's going to come down, and that is a law, and that always happens. That's always true. So there is no experimentation for laws. For theory and for hypothesis, you have an explanation. For laws, you don't have any explanation. That's something which is always true. So in general, for scientific method, the first step is observation. So step one is always observation. When you see an observation, you have an initial explanation for that, and that's the hypothesis. So step two is the hypothesis, and that's always initial explanation. So when you have a hypothesis and you have an explanation, the next step is to design some experiment to prove that if your hypothesis is right. So that's step three. So there are two possibilities with your experiment. your experiments either prove and supports the hypothesis, so that's this way. If the evidence supports the hypothesis, then usually we have more and more experiments, so you check all the aspects of your hypothesis, and if everything, all the experiments supports the hypothesis, then it becomes a scientific theory. If it doesn't support the hypothesis, it means your hypothesis was not right. So what usually happens, you go to a new hypothesis. So you have to revise your hypothesis and make it right. And then you have this loop. So it's going around. And this loop happens multiple times so that you can come up with the right hypothesis that your experiment supports it. And then you go to this route and then end up with a theory. So let's have an example to compare theory and law. As we said, law is something which is always true. Okay, so let's talk about the law of conservation of the mass. We know that in a chemical reaction or a physical change, the mass doesn't change. We cannot make or destroy the mass. So the mass is always the same. That's a law. So it's true. There is no explanation, and that's always true. You can see that this law was discovered at 1785, but it was not explained until 1803. So it was still a law, so which was always true. We didn't need any explanation. We found an explanation in this year, but even before that, it was a law because it was always true. However, in the 20th century, we learned about the nuclear reactions. And in nuclear reaction, we have a change in the mass that this doesn't apply to that. But so you can see that sometimes for some law, you can find new areas of research, new areas of science that the law might not support that area, but it's still a law because it covers most of the reactions. The nuclear reaction, if you can count it as a chemical reaction, if it's not a chemical reaction, but the law of conservation of mass covers all the chemical and physical reactions. So as an example, to make sure we understand what is hypothesis and what is theory, we have this example. A scientist conducts a few experiments in her lab and comes up with an initial explanation for her observation. What is the proper term for this initial explanation? Again, we have this initial. So when you have initial explanation, it's hypothesis. Suppose that the scientist and several of her colleagues conduct numerous additional experiments, and none of the new results contradict the original explanation. So all the new experiments still supports the hypothesis. So if everything supports the hypothesis, what is the proper term for the explanation at this point? So if our experiment supports the hypothesis, now it's upgraded to theory. So to have a recap on the things that we learned in this video, a scientific law is an observation that is always seen to be true. It does not need any explanation, it's always true. A hypothesis is a tentative explanation, or let's say initial explanation for the observation based on available evidence. If many additional experiments support the hypothesis and no evidence is found to contradict it, to reject it, the hypothesis becomes generally accepted and is now upgraded to a theory because all the experiments supports your hypothesis. So now it's a theory. A hypothesis can be a theory if the experiment supports it, but a theory can never become a law because laws are simply observations, whereas hypotheses and theories are explanation. For laws, we do not have any explanation. This is something which is always true. So that was the end of our first video.